I'm going to leave the video off if that's okay with everyone, just because the internet is known to crash at this hour, because I live on a busy street and everyone has Bluetooth.
All right, okay. So our second talk for this morning is Jeff Wurzbach, and he is talking about RemoteID. Okay, over to you, Jeff. Jeff, are you muted or not hearing anything from you? Okay. So Jeff has just messaged me to say the Zoom window has vanished on his display, and we're still viewing your screen there, but he is muted. I'm just chatting to him over in Discord to try to get him sorted out. Sorry about this. He says he needs me to unmute him.
I think I found it. It just moved.
Great.
Multi-monitor Zoom drama. Okay, so we will talk about RemoteID now, I guess. So let me go to the next slide here. So I spent a bunch of time trying to put this together and kind of summarize the last several years of RemoteID discussions and the little updates I provided in the partner calls and in some of the dev calls. So this is mostly confined to FAA regulations, and I'm also not going to discuss FRIAs, which are basically like FAA designated flying fields. So like your community-based organizations like AMA or whatever would operate. For those of you who've been to San Diego, that'd be like CEF and a few other places. So I'll start off with some origins of RemoteID and some discussions on that. RemoteID as a requirement is largely been motivated by a law enforcement and security organization request. At the very first sort of large meeting of FAA types, industry, etc., I would say close to 50% of the participants were law enforcement. And industry had a few people there. There were a lot of people from MITRE, which was doing some sort of consulting work for the FAA, and a few other people. Both broadcast and network RemoteID have been considered throughout the rulemaking process for Part 89. However, broadcast is the only one that survived through to actual rules. In the NPRM, there was a network requirement. The NPRM is the Notice of Proposed Rulemaking, which was the draft version of the rule. The systems that are required in the rule predominantly cover non-malicious operators. There's a few things in there to prevent tampering, but those are kind of vague. There was a large RemoteID ARC that preceded ARC being Aviation Rulemaking Committee or Commission, I forget which, that preceded the release of the proposed rulemaking thing with the draft of the Part 89 rule. As a result of some of that, also, you see Open Drone ID, which is created by a gentleman named Gabriel Cox at Intel, and I believe Tom also worked with them, worked with Gabriel back when he was at Intel, and that led to the creation of the working group that wrote F3411 for ASTM. And I've been in the F3411 working group from basically like the first or second meeting all the way through to the present day. The last meeting was when it went to ballot, like the first week of February. A lot of effort was made to try to make global rules that already existed. So the French regulators put a Wi-Fi based protocol out, and there's a few other AST Stan and a few other people have put together some proposals and rules. So the F3411 group tried to make sure that we didn't step on those or make incompatible requirements. Another thing that was interesting in the F3411 working group is we had a lot of people from national labs and other places that were looking at detect and avoid and sort of TCAS style systems to allow, aircraft to autonomously avoid each other in the same way that we see with like ADSB on a transport aircraft running TCAS. That's currently out of scope for this round of the rulemaking, but it's something that was discussed enough and enough money was put out. I suspect it will be in the next round of rulemaking. In terms of requirements, the FAA's rule requires that all vehicles have remote ID shipped or a remote ID implemented in some form by September 16th or 22nd, depends on who you're asking, 2023, unless you're operating within a FRIA. All vehicles delivered new to customers by the September 16th of this year must support standard remote ID. And if you're doing a Part 21 certification, you can either do standard remote ID or ADSB out, depending on what your requirements from the FAA are. And you may also have to do both. It like something the FAA I think is going to do on a case-by-case basis. All the manufacturers of a modular remote ID device or a standard remote ID device are required to submit declaration of conformity to the FAA, which is covered in the aviation circular linked there, which is AC 89-2. So I want to cover the difference between network remote ID and broadcast remote ID, as I think that's pretty important to some of the history and implementation details here. So network was really heavily pushed for in the US by mobile network providers, so your AT&T, Verizon, so on and so forth, with the envisionment that those would be like an LTE or 5G based. The vehicle or the ground station would have the actual link to the network. The remote ID messaging would be sent to a third-party unmanned service provider or unmanned something or other, whatever USS fanned out to be. This was something that a couple companies applied for, so like Google and whatnot had those. And those services would then allow an interface between the other service providers and also into a larger unmanned traffic management system or air traffic management system scheme. Obviously, putting a 4G or a 5G radio in every vehicle is super expensive and quite prohibitive from a power, weight, and cost and whatnot point of view. Broadcast is a little bit easier to work with, well, a lot easier to work with. It's going to behave a lot more closely to like ADSB. The radio on board the aircraft will broadcast the messages, and as long as you have a compatible receiver, you can receive those messages, whether you're in the air or on the ground. It's a decentralized system, so if somebody, denial of service attacks AWS, or AWS screws up, or somebody messes up a bunch of BGP tables and drops half the internet, you're not going to break the system, whereas you would have that problem on a network basis. Just a quick implementation timeline. In 2019, at the end of 2019, the remote ID NPRM went out in the Federal Register. There's a comment period. On January 15th, they published the final rule in the Federal Register, and then some corrections were published. There's a revised effectivity date. And then we fast forward to a lot of technical work in the committees to earlier this year, which is where we see the means of compliance document that we worked on in F3411 and the F3411 version 22-22 ballot close. Currently, we have a very small number of months basically before anyone shipping new hardware into the US regulatory domain has to have remote ID fitted in the form of standard remote ID. So there's some differences between standard broadcast and modular broadcast that are important to note. A standard broadcast system is integrated into the aircraft. From takedown or from takeoff to shutdown, you must transmit the items enumerated in the slide, and this is a requirement to get BV loss, which I believe is going to be covered under Part 108, but I'm not exactly sure. And then if you have modular broadcast device, this is like an add-on device that kind of sticks onto your drone, kind of like you might put an AirTag or a tile or whatever on something you don't want to lose. From takeoff to shutdown, you have to transmit the information enumerated, and this will be limited to visual line of sight operations only. Are there any questions so far?
Yeah. Hey, Jeff, this is Tom Pittenger.
Tom.
You had mentioned something about ADSB out being an option for certain things.
Yeah, let me go
earlier?
back to that slide. So that's this guy here.
Yeah, because we've had issues where, the FAA can't decide if we should be one or the other, depending on airspace
Yeah.
and altitudes and all that.
This is so this is from one of the FAA's publicly released, things on their website. So they said you can do one or the other, but it's up to them to decide what you have to do. Is kind of the way that I read their public information on that. There's probably some behind the scenes stuff going on there. And there may be some people who are in charge of that, but may not necessarily have the power to make that choice.
Now, is
if
that
that makes
dictated on the
sense.
aircraft or on the flight mission, altitudes or whatever, flight
So I
profile?
believe this is based on the aircraft. I don't believe this is based on like mission specific exemptions or flight plan specific exemptions. But I'm not 100% sure, as I haven't really followed the Part 21 stuff in heavy detail.
Okay, thank you.
Hey, Jeff, sorry.
Sure.
So the requirement for the drone ID is only on new vehicles. If you have an older vehicle, you don't need to retrofit it.
That's, yes, you do have to
Sorry if I missed
retrofit. That's the first bullet point here. So you must
Ah,
retrofit
sorry.
all vehicles in the airspace, all drones in the airspace by September 16th, 2023, must have some form of remote ID implemented. Whether it's modular or standard is up for debate or up for how you want to move forward.
Okay, thanks.
So, yeah. Alrighty. Go back to where we were and move forward if there are no more further questions. So one thing that is kind of frustrating for me, having worked on the FCC certification of control links and other systems, transmitters, that kind of thing, is the discontinuity in the use of the term modular. So the FAA's version of modular for the purpose of Part 89 is this stick-on kind of all-in-one remote ID device, which has an FCC ID, it's user and field swappable, so on and so forth. Whereas the FCC's rule on the term modular is a modular transmitter, which you can have full modular or limited modular. This is a self-contained radio device. So like when you're looking at like an ESP22 and it has the RF can over most of the circuit, and then there's maybe a little inverted F antenna, that's designed as a module from the FCC's point of view. So this kind of is frustrating, but it's something that's very important when you're looking at some of the words being used here. You can use a modular radio to comply with standard remote ID, even though it's not modular remote ID. So it's kind of a weird situation, which I found this quite frustrating. I wish they would use consistent language, but it is what it is. So in terms of implementation of what needs to be done, so we have F3411 at version 22, which is just the year. That will be what is leveraged in a lot of the means of compliance documentation and other templates, and a lot of what has been socialized with the FAA to date. Open Drone ID is basically F3411 with some extra stuff bolted in. There's another item here which is worth considering, which if you go and read the ballot history on F3411, there's some people who are rejecting, who submitted negative with rejection or with reason on the F3411 standard because of this patent, which is indicated here. So this is patent is by a gentleman named Kenji Sugihara. He wrote a white paper in 2017 during the remote ID ARC, and then filed a patent on it. There's some controversy over this because people are concerned that patent trolling is going to be a problem. The conversation with Kenji about this and preparing for this, and he's indicated that he is willing to license. He's willing to license, under reasonable terms. He's not going to be a troll. But one of the principal requirements that he has is that pilot privacy and safety be respected by the systems that display this information. So basically, if you're writing an app that is going to display the location of the ground station to users, you need to do some things to respect and make sure that it's not easy for someone to just point their phone at a drone, grab the remote ID information, go track down their ground station, and cause them to crash the drone or whatever. And if you're in any of the operation, like the commercial UAV groups here in the US that are posting on Facebook, this is a fairly common problem nowadays where people are menacing the pilot. And because remote ID requires that GCS location is reported, part of what Kenji wants out of this patent going forward is some provisions for safety on the pilot to prevent someone from harassing the pilot. The other item that is of note in implementing remote ID is going to be tamper resistance requirements. The FAA has a tamper resistant requirement that is like, it shall be tamper resistant with like no further commentary. And so the way that this has been interpreted through meetings with the FAA and also some of the discussions in email and whatnot with FAA is that it needs to be resistant to low skill attacks, so like if you smack it with a hammer, it's not going to necessarily break, but it doesn't need to survive repeated smackings with a hammer, if you will. Runtime options to disable remote ID should not be allowed. Being able to tamper with the messages in runtime should not be allowed. And to disable it, you need to have skill. So if you were to build a custom version of firmware, that's not under scope for tamper resistance. But if it's changed a parameter to disable remote ID, that is not tamper resistant, if that makes sense. And I really don't like the way the FAA worded this. It feels like it was bolted on with not sufficient review, and its lack of rigor and sort of detailing definitely makes it a very hard requirement to work to. So it's just a little bit more information like on what OpenDroneID versus F3411 discuss. So F3411 is the ASTM standard. It basically covers network and broadcast requirements, and it has a few implementation details, and it also has a few details for how network systems would communicate with each other. So like if Google's system had to communicate with, say, Facebook's system, for example. OpenDroneID is more, here's code, this code runs and is demoable. And Tom, I know you worked on some of the early demos for OpenDroneID, or what became OpenDroneID. And also some of those demos have been extended to run on an ESP32, not just a TI Bluetooth system on chip.
Yep, correct.
So I do want to remark a little bit on Wi-Fi versus Bluetooth and why Bluetooth is better. Bluetooth has a 2 megahertz wide channel. You end up having to work with both Bluetooth 4 and 5 within the US regulatory scheme, but that's not a huge deal. Any SOC that does 5 will do 4. You need to have an LE coded PHY, which is the low energy PHY, and you need to have advertising extensions in the device, which are both of those items. The last two items are optional features in the Bluetooth system. In Wi-Fi, you end up with a 20 megahertz wide channel running in a 2400 to 2485 spectrum, which is our 2.4 gigahertz ISM band here in the US. Remote ID will run on Wi-Fi beaconing, or it'll run on NAN. However, NAN is not likely to meet the FAA requirements, so I would just stick with beaconing. There's a bunch of other negatives about Wi-Fi, which leads to Edna Mode from The Incredibles. No capes, no Wi-Fi. We're good. So please use Wi-Fi if you're going to use it as a back fit. Don't use it as a forward fit or a new design, because Wi-Fi is such a menace to deal with from an RF spectrum point of view. It's spectrally inefficient. This is using Wi-Fi for remote ID would be like building ADSB all over again. It's just not a great way to accomplish the goal.
For the record, I'm in favor of doing ADSB all over again, though.
I agree with you that ADSB needs to be redesigned, but there's also a lot of people who won't even touch that with a 50-foot pole too. So anyway, if Wi-Fi is your only option, like you have a little itty bitty racer that's just over the, 250 gram target, then fine, use Wi-Fi, but otherwise use Bluetooth. The other thing is that Wi-Fi has a clear channel assessment, which is loosely a listen before talk. I'm taking some liberties with the actual correct terms there, but get the point. Basically, if you have two Wi-Fi radios right on the same aircraft, they will walk all over each other, especially if they're in the same channels or the same area of channels, because 1, 6, and 11 are the only whole channels you get in the US. And so if you have a remote ID system on channel 1 and you have your aircraft C2 link on channel 4, they're going to interfere with each other and you're going to have a bad day. So you're going to get huge hits in your performance. You're going to get, latency, lag, dropped connections, all sorts of other negative stuff that you just don't want to deal with. One thing that did come up during F3411 discussions was some of the capacity stuff. So I wrote up a quick back of napkin level white paper, if you will, that was presented at one of the meetings, which talks about how many aircraft you can have in a given area for Bluetooth. So I said, look, 50% of the airtime is going to be allocated to other users because it was a number. And I assumed the drone was a sphere, and that gives you a minimum 45 meter separation, and you get at least 99 aircraft in a 1 meter by 400 foot AGL section of airspace. And you can get up to about 996 aircraft, assuming perfect conditions, no one's colliding with each other in terms of RF, there's no retransmits or anything like that. Where I got the 99 number from is if you go back and read some of the old papers on the Aloha radio network, they saw a lot of loss due to retransmits and collisions. So I picked one of the more pessimistic numbers of 10% of that. So that's how you get that. So 99 aircraft in a space that big is pretty crowded, I'd say. And I think if you're up at the almost 1,000 aircraft in that small of an area, you're looking at like this is a drone delivery hub, and there will be other measures taken there. So too long didn't read. There's no issue with capacity on Bluetooth. I did not repeat this calculation for Wi-Fi because Wi-Fi is stupid. So another item that was brought up mostly by the law enforcement community is, if we can see it, we want to be able to identify it. So how do you get to a range requirement? So you can start writing link budgets and make sure that you've picked the right stuff. Well, you can use DORI, which is detect, observe, recognize, and identify. Or Johnson's criteria if you're reading some of the older papers. The way that the FAA wrote the rule is you have maximized range within your wave law requirements, so within FCC requirements, within CE mark requirements, so on and so forth. So I did some calculations again, assuming the drone is a sphere. So we have some various sizes of drones in this data table at the bottom here, showing basically 1 foot all the way up to like 4 or 5 meter wingspan type aircraft. Again, I made a sphere out of them, so math. But you find out that very quickly your ability to recognize the object falls off quite quickly, within 200-300 meters. Your ability to detect it basically is gone by about 500 meters, and the minimum human performance for angular resolution, you can go out to over 1,000 meters, but that's not a realistic. That's like you're actively searching for it. You have, some other situation going on that's not your normal 99% use case. If we switch this over to look at RF link budgets, the red line on here is about minus 70 dBm, and that's where the Wi-Fi clear channel assessment stuff starts to come into play. The purple line is about minus 95 dBm, and that's where you start to run into receive sensitivity limits for your individual radios. And we look at this, and at 1,000 meters, pretty much everything just works for sensible link budgets that are based on actual like procurable commercial off-the-shelf designs. So at about 1,000 meters or 1 kilometer, everything just works. And there are demonstrations of Bluetooth working to well past 1 kilometer. So again, Wi-Fi is stupid. Onto some of the data packaging items that are needed for RemoteID. So for the vehicle location, basically, as long as you have a GPS or GNSS module that has GPS, that implements SBAS, specifically wide wide area augmentation system. And yes, I screwed up the acronym there. And it's passing the pre-arm checks that RGPilot comes with. You comply with the horizontal requirement. Just that done. You don't even need to talk about the requirement in numerics. It's just you comply. The controls that are needed, so your EKF and whatnot, already require higher precision and higher accuracy systems than what the rule requires. So even your barometric pressure, as long as you have a baro that works, you meet the requirement. There's further detail in part 89 if you want to get the actual numerics. Where you do run into some grief though is GCS location. So the GCS location is actually much tighter than the aircraft location. However, the FAA did kind of mention they're willing to consider some level of relief over their atrocious requirement, which is basically if you have an internal location source on your GCS, as long as it uses GPS with SBAS, you're fine. Or if you have an external device like a tablet or a phone or a laptop, it needs to have a GPS that uses SBAS, or it needs to be FCC certified as a personal wireless device. And that's because it will be able to provide position solutions at the intended tolerance. And that's because the original requirement that's in the rule appears to be based on E911 service requirements. However, you can't use E911 data for non-911 purposes. And in the US, 911 is our emergency services phone number.
Hey, Jeff.
Yeah.
Hey, Jeff. This is Bill Geyer.
Mm-hmm.
Hey, so I guess there's been some discussion on the chat, but could you describe, I guess, from the standpoint, this remote ID is required, but aren't there, what are the situations, like if you're only flying visual line of sight, do you have, and your aircraft doesn't have a GPS on it, are you still able to fly? Because obviously your remote ID is not going to get that information. Does the GCS satisfy the requirement then?
So there's two answers to that question. One is modular remote ID, or two, fly in a FRIA. Those are your choices.
So the FRIA is, okay, that's the FAA recognized flying site.
Correct.
Okay, and then the other one is, you said modular. I'm sorry, explain that to me again.
Go back to, whoops, went too far. There we go. So add-on device, basically think like Cube Purple with a GPS and a radio.
But it has to be on the aircraft?
And it has to be on the aircraft.
So there has to be something on the aircraft that has GPS to give it a remote ID. Okay.
Yeah, this was something that.
Okay, so so the FRIA gets you out of that. But if you don't have a FRIA, then you've got to have something on the aircraft.
Yeah, and registration for FRIAs is limited to educational institutions and community-based organizations. So like my company can't apply to have a FRIA to fly in without hardware that has remote ID. So if I needed to fly hardware that wasn't carrying remote ID, a prototype or a project that was going into an environment where remote ID was not required, like military, I would have to go to the FRIAs that are here or get like the local university to spin up a FRIA so that I could do that testing. Or I'd have to go to a military base because the military airspace is exempt from all this. But if you're just regular flying like a glider, like a super old school glider that basically is just like full RC, and you got to put remote ID on it, or you're in a FRIA and you're limited to the extents of the FRIA. So this was something that really did step on a lot of the traditional like old school RC world's toes, and I think definitely was a little bit of an overstep, but that's my personal opinion on the matter. And unfortunately, the rule's written the way the rule is, and it covers everything. So if you're flying traditional normal RC, you have now been, invaded by the drone industry, so to speak.
Thank you.
Jeff, sorry, is there a requirement that the GPS has a good lock? Like I don't know whether it's a modular unit that you've added on at the end, or you're using the autopilot.
Yes, so that's covered in the technical requirements, nominally covered in the technical requirements for the specific, like how you implement it. That's covered in the means of compliance document. And basically, like if you're like HDOP is reporting. And I know HDOP is a terrible metric, but if you're getting terrible HDOP, you're not going to take off, if you're flying as an autopilot. A lot of this stuff was assumed in sort of standards design, regulatory design, as it's flying on a drone. And so when you have the modular thing, a lot of the pre-arm checks that we're used to seeing in a drone were roughly assumed.
Yeah.
So like if you were
sorry, just noticing, that, we have a whole lot of pre-arm checks that apply when you're flying in, semi-autonomous modes like loiter or whatever, but you can bypass a lot of those by flying an alt hold, for example, where you're just controlling.
Yeah. So
you don't need a GPS for that mode.
Yeah, the remote ID requirements will probably facilitate or necessitate some changes to pre-arm behavior, in that like alt hold you can take off, but you have to have enough precision to make the remote ID happy.
Yeah. Okay.
And that'll fall strictly, that's not ArduPilot's problem, that's the vehicle manufacturer's problem, and ArduPilot is not a vehicle manufacturer, but I think in reality there will be some changes to the code base precipitated by some of these requirements. Okay, I think we were here. So the next thing to talk about is antenna or module position on the aircraft. We spent a lot of time talking about this in F-3411, specifically like how do we define omnidirectionalness? Because we didn't want people using creative positioning of deep nulls to in the antenna pattern and radiation pattern of the antenna as it's positioned in the aircraft to make remote ID not work from the ground user's point of view. So we basically fully defined that. I'm not going to try to reproduce that information here. Check the standard, check part 89. It's also in the mock. And those three items together will give you the required information. It's also vehicle specific, and you may have to test for this. An integrated antenna on your radio device will force you to place your radio device where the antenna needs to be. So I would not recommend using integrated antennas. Like if you have a little module with like say you have an ESP32 module with an inverted F antenna on it, I would not use that if you're given the option to have like a little UFL or like MCX type connector. I highly recommend you go with the external antenna option, where you can place the antenna where it needs to be in the airframe to meet the overall radiation requirement, because the radiation requirement is based on the aircraft. It's not based on the antenna. Even though there's a lot of language in there that sounds like it's written for the antenna, that was written because we were trying to make it so you could do this with a datasheet analysis and not have to hire a company to do like a full, EM simulation of the aircraft and the antenna and all that kind of stuff. We wanted it to be something you could analyze with data sheets. So there might be some confusion there for some people, but the intent of the FAA is that it is at the aircraft level, not the antenna level. And going to market. So how do we get to market if you're a manufacturer? You integrate the required hardware and firmware. You're going to need to grab yourself a copy of CTA 2063. And in that, you're also going to end up having to go get a manufacturer code from ICAO. Because Wi-Fi is stupid and we don't consider Wi-Fi, we only consider Bluetooth. You need, and by we, I mean me, you need to go to Bluetooth SIG and get yourself set up to have your end product ID. You'll need to do your FCC testing for your aircraft so that you have co-located radio stuff. There's a whole lot of discussion about co-located radios, which I'll get to in a second. And then you'll need to do your means of compliance, which feeds your declaration of conformity, which is part of your FAA requirements for being an aircraft manufacturer. So I want to talk about the co-location of the radios and some of the implications this has for aircraft manufacturers, as well as the manufacturers of C2 links, so your command and control links, your video links, so on and so forth. Definitely, if you are working as a manufacturer and you are going through the cert process, you need to talk to your test house and also probably the TCP provider, who will give you some more information on this that is immediately relevant to what you're doing, because they'll have your test reports that you already have, or they'll be helping you generate your test plan. So it's super important to talk to your test house, whether that's UL, TV, CKC Labs, SGS, whatever. If you're using a module for your radio, so like you're buying a pre-made radio module from like TI or ESP32 type module, or you're buying a module that carries one of the Nordic radios, you need to have support from the manufacturer of the module, because if you don't, you can paint yourself into a corner where you've got a product that's basically done, but you can't get it through your final FCC testing. No FCC testing, FAA will reject your DOC right off the bat. So also some other considerations, some of the overlapping beam patterns of antennas can also mess with your transmit power limits. So that's again goes back to work with your test house, and you're very likely to require permissive changes to FCC IDs on your radio, your C2 radio, and also your radio module that you're using for remote ID. Unless the manufacturers have specifically tested for this use case and it is specifically enumerated and discussed in their certification documentation and test reports. This is probably something that needs a lot more time to go through and discuss, because this is a hugely complex topic, but it was something that I wanted to make sure that at least at a summary level, everyone is aware of. Are there any questions thus far? Awesome. We get to talk about every electrical engineer's favorite topic these days, chip shortages. So there are basically two chips that are not ESP32s that are workable in this particular design. The NRF 52840, the CC2640 R2F. As you can see, it's kind of a bloodbath. At best, there's going to be a few thousand 52840s in distribution coming in June, and there'll be a bunch coming in sort of end of year of this year. When we start looking at the modular or the modules for these radios, it's low stock, no stock. You can get the Fansteel BC840, which I think there's a few thousand pieces of, but I'm not sure there's enough pieces to support rate production for anyone in the US that hasn't already bought material. So that is a huge concern. The FAA may have to address this, but yeah, it's going to be frustrating. I will say that much. So if you're a manufacturer, what can you do now? Go pick yourself up a copy of 2063. Once F3411-22 is available, pony up the $91, buy yourself a copy. Once the MOC template is available, pony up the money for that, get a copy of that, and then go grab a copy of 14 CFR Part 89, which is the actual remote ID rule. Get your manufacturer code from ICAO. That's free. It doesn't take that long. I have some links on my website to where you can just click and get these things done, or it'll give you the instructions for how to get them done. Get yourself registered with the Bluetooth SIG and understand how they're going to basically take you through to get your end product listing. And then also work with your command and control link or the other radio vendors on your vehicle, so that when you do go through test, you're in a position to succeed and you're not having to like emergency rush, all that kind of stuff, because some of those things can take many weeks to get all the right paperwork in place for. I managed to do an hour and 30 minutes. Questions?
Hey, thanks, Jeff. A lot of good info there. I do have a question about, you'd mentioned the ICAO, ICAO numbers.
Mm-hmm.
No, that's typically, I've seen that with ADSB.
Mm-hmm.
So that's going to be a number in remote ID? Is that a new number?
Yeah, so if you go look in Part 89, basically the serial number or unique ID that you need to transmit contains this, or it contains the CTA structured, the CTA standard for a serial number, and that references the ICAO thing. So you have to have an ICAO manufacturer code to generate your serial number. You have to have your serial number to generate the remote ID message.
Okay,
so when you fan all the requirements out, you have to have your ICAO code.
Right. Well, the ICAO code right now is based on your in letter or in tail number. I'm not sure about the manufacturer code.
Yeah,
right.
The manufacturer code's different.
Right. Okay. So because that's been a big problem with ADSB is drones can't have an ICAO.
Yeah, you can't have like a tail number. Yeah.
Right.
The message packs support, I think the messages support transmitting a tail number. So like if you do have a tail number, you can transmit it, but it's designed to also support, I think, a session ID or a serial number for the aircraft.
I got a question. So I guess, sorry, great presentation, obviously. There's definitely a lot of information here, especially for like the manufacturers of these devices. And, I guess there's also a big number of people who are interested in this who are not manufacturers. They're, for example, people selling drones, maybe, people with their personal drones, and they're, within 6 months or something, they have to put one of these drone IDs on there. I mean, are there manufacturers who are selling these right now that I can, buy?
There are currently a few manufacturers who are building units mostly for test and evaluation. So there's a company in one of the Eastern European states. I forget which one it is. The gentleman's name is Lucas, but his company makes a module that sticks on. You just have to give it power. I've got drawings about half done for like the full integrated, can be put down on a main board type of arrangement. There's a company specializing in more of the defense applications here in the US called Pierce Aerospace. And I think there's one or two other companies that I've heard about but haven't really investigated, and their names are escaping me at the moment. But there will be a litany of manufacturers. But I mean, literally the technical goalposts for this effort have not even been released publicly. I mean, like until 3411-22 is like a purchasable standard, theoretically, your goalposts haven't been set. So there's a huge amount of like pressure to quickly release this. There was a huge amount of pressure within the committee to like try to get this done. But, the timeline on this is unfortunately incredibly compacted for, potentially synthetic reasons.
Yeah, it seems like that for sure. I mean, we're only talking about 6 months, and even like our ArduPilot, say we had to make some changes in ArduPilot or something like that. Our release cycle is 6 months long. Although of course we can do point releases and stuff.
Yeah,
and that's software. Like not even talking about people who
hardware
build
was
drones and sell it.
Sell the hardware side of this is usually like 12 to 18 months for a cycle.
Yeah.
And we in 3411 knew that, but you still have to go through a process. And so we went through as much of it as we could, as fast as we could. And it's worth noting that the FAA is sensitive to this, but there's also certain things where the FAA cannot, move a mountain in a day. And so maybe we get some, stuff that says, hey, we're going to give you a pass because you're not even going to have a physical piece of hardware until, December 31st of 2022. And so maybe we get a pass on that. I am not counting on it, but the chip shortage has definitely put a huge spanner in this.
Yeah. Yeah, it seems a bit like it seems like the final deadline is not moving, but the the requirements or just things are not getting clear enough quickly enough to actually meet that deadline. There's stuck the stake in the ground, but they're not actually giving people or manufacturers the ability to meet those deadlines because some other requirements like how to actually what is a requirement is not completely finalized. Seems a bit unfair to me.
Yeah,
it kind of reminds me of ADSB.
How does that stick on unit? How does that stick on unit compliant? How does it stop the vehicle flying if it doesn't have a suitable GPS lock?
That's the pilot's problem. All manual.
Oh, so in other words, RemoteID doesn't actually need to enforce this.
No, RemoteID only needs to enforce it if it's standard. If it's modular, it's the pilot's problem. So with modular, a lot of the stuff in modular, a lot of the like, are you ready to fly? Is the system ready to go? All those types of things have to be announced visually, audibly, whatever. It's not designed to require a firmware change in the vehicle. Now, that being said, if you did, let's say we took like OpenSolo and we made OpenSolo comply, using the Wi-Fi card. Even though Wi-Fi is stupid, it's an option. Like Wi-Fi exists, the Wi-Fi option exists purely to do backfits. OpenSolo at that point would then become standard remote ID compliant, and it would then have to meet the requirements of, you know, no permission, no fly, so to speak. Or if the remote ID system is not fully functional, the aircraft can't take off.
Right, and which standard you comply to depends on whether you can do BVLOS stuff, recollection.
So it's up until basically September of next year. Let me go back to that slide. You know, up until, you know, September of 23. Yeah, if you're going BVLOS, you have to have standard. But at September of 2023, if you have a modular device, you're still limited to VLOS, because the modular device can only report takeoff location. It can't report ground control station location. And because you can't report GCS or control station position, you're not allowed to do BVLOS.
Right, but our partners who do want to offer BVLOS aircraft in America will need to.
It will need to be
a standard of some
standard
module.
Yeah, it'll have to be standard. It can't be modular. Now, that doesn't mean that they can't put a module in their vehicle, right? Like you can build, like I could build a brick that's like a machined aluminum housing that, you know, harnesses into the system, but they have to like glue the connectors to, you know, to the main board, glue the connector that, you know, is provided out of my device, place the antenna, glue the antenna on, that kind of stuff. So they have to still meet the tamper resistance requirement. But, you know, it's like there will be like people who are making like a box or a brick that you could install inside your vehicle to make it standard remote ID compliant, but you will have to take steps to meet the tamper resistance requirement.
So if that notional box you just described goes into an aircraft, how do you imagine that would stop the aircraft flying? Would it be RG Pilot responsible for looking at interrogating that device, or would you actually cut some signal lines or something?
You'd have to, if you were to cut the signal lines, you would probably do something like it would sit in between your telemetry link path. So you wouldn't get telemetry if it was the wires were cut, and you'd probably have some sort of command that would have to be sent to the remote ID device to say, hey, are you ready to fly? And again, this could be telemetry, it could be drone cam. There's a number of ways that you could do this. The FAA does not prescribe how to do that. They just say that you must have this feature.
Yeah, I'm just trying to work out whether RG Pilot needs to be able to prescribe this, or whether, you know, you can do it just in magic black box, which either enables your vehicle to fly or not.
You could do it as magic black box. I'm not a fan of that architecture, because if the magic black box crashes, the aircraft potentially crashes. So I'd prefer to have it be more of a RG Pilot interrogates the device, but the device doesn't, you know, have the ability to like nerf RG Pilot, so to speak.
Well, we have to enforce that nerfing ourselves if people are flying this vehicle in America. So, you know, we don't have parameters and whatnot.
Yeah, but it's one of those things where, you know, the software stack for these, you know, remote ID devices will be substantially less mature than, you know, the flight code. And, you know, if you have bugs that are due to, you know, lack of maturity in the software, so to speak, and that bug causes, you know, a lockup. So like, let's say you're doing like PWM pass through, where it's like the thing just disables the PWM lines to an ESC to deny takeoff. If you have the processor that's running remote ID lock up, all of a sudden your PWM lines go poof, and now you have, you know, no throttle signal to the ESC, and so your aircraft crashes. So those types of things, like from an architectural point of view, I'd rather have RG Pilot be responsible for, you know, basically incorporating this almost as a pre-arm check, than have it sit, you know, in the hardware somewhere where it can like remove control surfaces or remove ESC signals or whatever.
Yep.
Just because I think that's a terribly unsafe way to do it. But
for
RG Pilot to say, yeah, for RG Pilot to say, hey, pre-arm check, remote ID not ready, remote ID not found. You know, that's fine. You just, you know, it's like when you set pre-arm check to 0, you would not be able to disable the remote ID check. You would have to rebuild RG Pilot without that pre-arm check in order to meet the tamper resistance requirements.
Yep. Yeah, we'd probably actually try to do that as a read-only parameter rather than actual.
That's fine. It's something. The other thing too is whoever takes this through the FAA first is going to do a lot of learning for everyone. And that's going to be very, very painful for that particular company, because they're probably going to have a lot of very rushed software changes to appease the FAA.
Yeah, that
the people
tamper-proof
that
thing means that, you know, the tamper-proof thing, if somebody can bypass these checks simply by upgrading their firmware from our firmware server, that's a problem.
Yeah, like I said, there's going to be a lot of things now.
Yeah, if that's too easy, according to the tamper-proof rules, then we have a problem.
Yeah, and the tamper-proof rule is literally one sentence: the device shall be tamper-resistant. Like, that's literally all it says.
Right.
And I know Tridge, myself, Philip, James, and a few other people have sat in a phone call with the FAA where we've asked them about this, and they won't give you a straight answer necessarily. It's like, we'll know it when we see it. is how I remember that phone call going, basically. You know, they don't want the go ahead.
Oh no, finish it. No, go ahead.
Yeah, so like they don't want it to be where, like, you know, you can just you can easily snip a wire, you know, or whatever. They do want stuff that's a little bit harder to destroy. You know, if they want solder down if possible, or glue down if it's, you know, got a connector on it, that type of stuff. But they do want some level of hardware, you know, resistance to somebody destroying it. They don't want somebody to just, you know, take the 4 screws off the housing and, like, you know, unplug the antenna, for example. That would not be sufficient based on some of the things that I've heard. They want that a little bit more ruggedized, so to speak. So, you know, cover the thing in glue meets the requirement as far as I can tell. You know, and like I said, the first group of people to go through this are going to do a lot of learning real quick for a hell of a lot of people.
Can I ask a question that's come up in the chat?
Sure.
Does this apply for flying drones indoors or underground, or
Not
is it
controlled
from what you
airspace?
said
It's only within the jurisdiction of the FAA. Indoors and underground are not controlled by the FAA. However, if you transition to be out of doors, not in a cage, now you're in FAA jurisdictional space.
Right.
So it's
Okay,
only where
so
the
if
FAA
you're-
has jurisdiction.
So if you're flying in a warehouse that's acting as a nice Faraday cage, and I can't get a precise GPS fix, then I don't have to deny arming for that reason.
Correct. Yeah, you don't have to deny arming. Now, the mechanics of how all that happens is not defined. Like, how do you define that? Like, if you have a vehicle that can fly indoors and a vehicle that can fly outdoors, how do you define how that transition occurs? Because if it's switched, like on the RC controller, that's not tamper-proof or tamper-resistant. You know what I mean? So there is a little bit of, I think, interrogation of the FAA's requirements and intents there that has not been done to cover that, because at a certain point, we were starting to ask these questions in committee, but then we realized if we keep asking these questions to the FAA, we're never going to release the standard and then nobody wins. So we did kind of have to prioritize the questions that we asked and go from there.
It sounds like if the drone flies out the door, then the FAA police is standing there and says, "Gotcha."
Yeah, pretty much.
What if you're like you're saying it's only if the vehicle's in FAA airspace? So if you're flying on your own property below 150 meters or whatever the rule is.
FAA owns all airspace.
Okay, all right.
Yeah, the airspace in the United States is federal jurisdiction. So that's another thing too that's been kind of interesting to watch, is like you see all these towns and ordinances trying to restrict drone use in their airspace, or in the town's limits. You can't do that. The airspace is federally restricted, but you can restrict where you take off and land. So a town can say it is illegal to launch a drone or to take off in a drone, but they can't say it is illegal to fly a drone, if that makes sense.
Yeah.
And then one last case is the tethered case. Is tethered considered?
Tethered requires it.
Really?
Yes, it is actually a specifically enumerated aircraft type in the dictionary, the data dictionary. And
Tethered wasn't even considered a drone. What if it was tethered?
It did. Somebody decided it was, and I remember when this happened. I just don't remember the specific circumstances.
Oh, I have another question about the BVLA stuff, I guess. Is there a definition of what counts as a GCS? Is that, you know, a transmitter, a radio transmitter, or is that
it is
anything that controls the drone?
My recollection of this was, and mind you, when I was working in the committee, most of what I was focused on was the kind of typical use case of, you know, who the person with the sticks is also the pilot in command, and that person is, you know, kind of a one-to-one. There is a bunch of stuff that was discussed about if you're like a drone delivery company and you have a warehouse full of drone operators, so to speak, monitoring a huge operation. But where the pilot in command is generally what they're considering the location of the GCS.
I see.
How are they dealing with the rather large body of you know, relatively ancient drones now out on the market, the vast numbers of Phantom 2s, Phantom 3s, Mavics, I guess, that, you know, just won't have the hardware inside to run this stuff? And
so
you know,
it's
making
it's
that tamper-proof
module.
afterwards.
It's the module has to go onto it, and otherwise the aircraft cannot fly in U.S. airspace. Those are the answers. Or they can fly on a FRIA. So there's kind of don't fly it, fly in a FRIA, or affix a module.
Sorry, another question about the GCS. So if this module on the drone is transmitting a location that it receives from the GCS,
correct?
And so what if the drone flies far enough VVLOS, or there's something in the way and it loses the Bluetooth signal? What is it supposed to do?
The Bluetooth signal's not part of the telemetry link. So if you have a telemetry link, you know, for example, you have a, say, a microhard, or like you have a SATCOM based telemetry link or whatever, you would transmit your GCS location over the telemetry link, and then the Bluetooth would broadcast that as part of the larger remote ID packet.
Oh, sorry, right. So you need a separate bidirectional telemetry for that. So I guess what I'm trying to ask is, if it loses connection with the GCS, then is it required to return?
There's a set of conditions surrounding that are discussed in there. I didn't work on that part too much, so I don't have an off the hand answer for you other than check the documents.
Okay.
There is it's like a minus 1000 error code that represents several different conditions there. You know, it's like, and also there is a specific emergency status that you can broadcast that says I've lost control link, you know, lost my like C2 link.
Just another question from the chat. So Scott Arrow asks, so if you have a drone show which has 100+ drones, each one has to have a remote ID?
Nope. There is a way to do that.
Oh, sorry.
There's a way to do 100 now. Given that you can put literally 1,000 drones in a pretty small area, yeah, you could put remote ID on all of them. But there is a mechanism for doing a drone light show that can be like you have a single module that is doing the broadcast, and it defines sort of a geometry in the airspace that has drones in it, so to speak. So there is a way to do that. But again, if you've got less than 900 vehicles, I would say it's probably easiest just to put remote ID on all of them and just, you know, see what happens.
Okay, thanks.
And by the way, the pentalobe screws thing from Connor in the chat, no, that does not work. We asked that question. So that was frustrating. They want stuff like glue. Yeah. That's pretty much, that's the polite version of my thought on that.
This is 250 grams up and up, I assume?
Yes. And I don't believe it applies after you cross 55 pounds either. It's different. different thing. Peter Hall's trying to get himself a felony there with his tinfoil hat. So yeah, anyway, this took a lot of stuff to get done, and there's a lot of stuff in here that is not an optimal engineering decision. There's a lot of stuff in here that is clearly written by regulators who have zero understanding of how things actually work. But unfortunately, it's the rules that we were given, and it's kind of falling on us, the engineering world, to fix it.
Oh, I know there was a lot of talk about, Wi-Fi is basically best for kind of retrofitting into older aircrafts. I know one of the things I've seen is manufacturers of modules. I think Doodle Labs was one of them, was potentially going to offer the ability to just make their Wi-Fi radios also broadcast out something remote ID compliant. I think that's still,
they could do that, but I'm pretty confident the test data that is getting fed back to the FAA in non-public domains will more than likely, in my opinion, eliminate that option very quickly in the next round of rulemaking. It will be backfit only, and if you want to use for forward fit and new design, you have to use not Wi-Fi. The Wi-Fi range the ranges of that Wi-Fi is pulling off compared to Bluetooth are just unimpressive. So there is a certain amount of Wi-Fi is available in the rule, but it is available and it was intended as a backfit. The FAA knows that, but if people are going to forward fit with it, I have a feeling the FAA is going to go no, because the FAA does have the right to say in your declaration of compliance and means of compliance to say no. And then you as an aircraft manufacturer are going to have a system you've designed around like Doodle's Wi-Fi system that is not compliant, and the FAA will not let you, market that aircraft. So this is one of those things where, yeah, Wi-Fi is available, but it's risky. It's very risky on a forward fit. On a back fit, that's a different story.
okay,
the FAA
yeah,
knows,
thanks. That makes a lot of sense.
Yeah, the FAA knows that backfits are going to have to be part of the solution, and Wi-Fi is part of that concession. But on forward fits, I don't get the feeling, they haven't publicly said anything to the committees. They haven't said anything on the public, public forums. And Yuri, your assertion in the chat is correct. Wi-Fi is stupid because it is unlikely to meet the requirements, and it is unlikely to meet the requirements in a time frame for which a design must survive from a business point of view. So yeah, the FAA hasn't said anything publicly about this, that Wi-Fi won't meet the requirement, but the reality is that the test data they're going to get, or they already have access to, will show that Wi-Fi is insufficient for the maximized range requirement. So I like, if in a business case, like if I take the engineer hat off, put the business hat on, if I were a business leader in this situation, knowing what I know as an engineer, anyone who suggested Wi-Fi would immediately be disqualified from speaking for at least an hour. It's that kind of like hugely expensive risk for a business that I just don't think is a wise decision to take.
What are the tamper-proof requirements for the ground control side of things?
It shall be tamper resistant.
Right. So if somebody wants
hate
to
be
fly there,
like I don't mean to be snide, Peter, but that's literally all they gave us.
But
it's
it means
very
that,
frustrating.
Somebody who's trying to fly their drone off their laptop, for example, and they've got a GPS unit plug, and tamper resistant is not really the word to be.
I know it. Like I said, it's bloody frustrating.
But it's like, the system as a whole which is tamper resistant, not just the stuff on the aircraft.
Correct. It's the system as a whole, and that's what's super frustrating, because also, like, you talk to Philip, who used to work as a Boeing, in one of the Boeing plants. A sticker that says "Do not tamper" was sufficient for manned aircraft. For like, if this floppy disk gets ejected, the airplane crashes, type of stuff. So there's some inconsistency in the rules here, which is super, super frustrating. The rules that the drone industry is being forced to adhere to are much, much, much more rigorous than what some of the manned stuff is being asked to do, which again doesn't seem fair, but it's the way the rules are written, and unfortunately, unless we're sitting on a few $1 billion to go lobby, we really can't move the needle.
All right. On that note, thank you very, very much, Jeff, for that talk. Great presentation. Really appreciate it. And we'll need to follow up on specific actions we're going to take within the project. And so I'd like to probably have some regular meetings with you about exactly what we do over the next coming months. All right. So thanks again, Jeff. And our next presentation is Leonard Hall. So Leonard, are you ready to go?
I believe I am.
All right. Well, over to you, Leonard.
Make sure I can make this work. All right. Let me, oops, I can start my video. Let me share my background, there's my screen share. All right.